This is the tutorial video for the Yamaha Montage Performance MFMX Slow PWM pad. I review how I constructed this performance in the YamahaSynth.com article series Manny's FM-Xplorations, but I'm going to do a little video breakdown of it as well, so hopefully make it a little more clear on what we talked about in the article. So this performance is a polished and finished example building on the basics of some of the things we covered in the multiple motion sequence tutorial video. Let's hear it up. So you can hear we've created that typical lush analog pulse width modulation synth type pad. How we've given a lot of that character. I've got 3 parts now. Each of these are basically identical. The difference is that they are slightly detuned and spread center, left, and right. In addition, I am using some effects on here, the Ensemble Detune Symphonic. So first, let's review what I've set up on our assignable knobs. For knob 1, we've got our carrier ratio. That's going to change our carrier frequency in stepped intervals from ratio 1.0 to 8.0. We've got our carrier wave, which is going to take us all the way from sine wave to our res 2 wave. We have our modulation index, or modulator levels, on knob 3. Knob 4 is set to control the fine frequency ratio of our modulators. Knob 5 is for the modulator ratio in the same steps of 1.0 to 8.0 that we have on knob 1. This is much more similar to the operator course parameter. And then on knob 6 we've got our carrier resonance. So the carrier wave and the modulation index come up with these default values, and the important one here is the carrier wave at 64. So basically we are starting with our odd 1 wave shape. So let's go ahead and play around with this a little bit. I'm going to go ahead and turn this up to a little over 107. This will select the resonance wave. So now our knob 6 will make a difference in our sound. So in addition to the knobs, I've also set up 8 scenes. And what I've done with these 8 scenes, these scenes are selecting different motion sequences. So I'm using it to change the pattern of the pulse width modulation. So the default scene 1 gives us the very slow pulse width modulation from square to narrow pulse and back. Going to scene 2, it's going to speed that up to twice the speed. Scene 3, we're going to double that again, so we're 4 times the original speed. Scene 4, we're going to change it to double speed, but instead of the triangle or saw smooth type of modulation, we're going to use a square wave. And then scene 5 is that one doubled again. Now if you want to hear our modulations a little more clearly, we can kill the effects. I've set up Assignable Switch 1 to do that. Back to scene 4. Now I mentioned we've got knob 3 controlling our modulation index, so if we bring that up, that's going to increase the depth of that. Turn it down to 0, there's no pulse width modulation at all. So I've done something a little bit different with scenes 6, 7, and 8. What I've done is I've linked knob 4 to our super knob so I can actually store particular values. So I've mentioned that knob 4 is the modulator ratio fine control, so this allows us to create non-harmonic relationships between our modulator and carrier. Again, I'm using the faster square wave modulation, but let's play around with that parameter on knob 4. And on scene 7, I've done something similar. I'm using a different stored value. But more importantly, I've gone from the fast square wave shape to a slow triangle shape. Let's change around our fine here to hear different versions. And now with scene 8, I've chosen a different shape for the motion sequence again, and we've brought our modulator fine setting to 127, which actually tops out the fine range, so it goes from 1.0 to 2.0. Now let's listen to that. So now you've seen and heard that from the performance level. Let's go in edit mode and show the actual components here. We're going to go ahead and just look at part 1 here. So let's look at our first motion sequence. And let's look what we've got set up here. And let's start with sequence 1. So this is our slow pulse width modulation shape. Sequence 2 is double speed. We're using the bell shape here, so we get a peak and fall all within one frame or one step of the motion sequence. And here is motion sequence 3, and each one of these has 4 pulses. How I've created this is the discrete saw shape, but by playing around with our parameters 1 and 2, I'm able to create 4 equal square pulses. Now you're wondering, well, that sounded smooth. That's because we're using the smooth parameter. So if we turn that all the way off, you hear the discrete steps, and if it's up nice and high, it rounds it off more like a triangle or sine type shape. And if we go to number 4, this is the halftime setting that we are using for our square wave. I just happened to use the B pulse versus the A pulse here, and I've got different settings for our discrete saw. So we have 2 pulses, and it sounds discrete because the smooth is very, very low. And now on sequence 5, again, I'm using the B pulse, again the discrete saw. And settings give us the 4 square pulses. Again, the smooth is 0. Now let's look at number 6. So number 6, we're back to the fast pulses that we had before, and we've got no smoothing. Number 7, we've got just a smaller version of our triangular shape. Now remember, this is the one that's modulating the inharmonic component, because we've also changed the modulator fine tuning with our knob 4. And then here we are with sequence 8. This creates our little Jacob's ladder type effect, because I'm using a discrete saw, but now I've got the parameters set up to actually create the sawtooth shape. So you can see as we change our parameter 1, we can change how many saw peaks we have here. And by changing parameter 2, we can change the shape. And that's how we were able to make it go back and forth between our 2 settings here. So now let's go out and see where those guys are all assigned. So we're going to go to our mod control, and we're going to go to our motion sequence lane 1, and basically it's just controlling the operator level or our modulation index for our 4 modulator operators. And we've got it set to bipolar mode, so it goes up and down, so it goes from square to thin pulse and back. So you'll see I've also got motion sequence lane 2 turned on here, but interestingly enough, if I turn it off, you're seeing it's not making a difference, and there's a reason for that, and that's because what it's assigned to is not active just yet. So go back to our mod control page, go to our motion sequence lane 2 display, and you'll see we're controlling operator resonance for our carrier operators. So we're not hearing this at all. And the reason why we're not hearing it is because it's not active. The reason why it's not active is our carrier wave is still the odd 1 wave. To create any effect from our resonance parameter, just like it's not doing anything with the knob, the motion sequence is not expressing any result in our sound because we don't have a wave that responds to that parameter. So now to hear the effect of that second motion sequence, we've got to set up our sound so that we actually have one of the res waves so that we can hear the resonance being modulated. So if we take our knob 2 and bring it above a value of 107, 108, that's going to change us from our carrier wave shape of the odd 1 to our res 1 wave. And now our carrier parameter has an effect. So I'm going to set it to 24 like I mentioned in the article. With our default scene 1, that resonance is static. But now I'm using motion sequence 2 to control the resonance in various shapes and speeds with the remaining scenes. So let's turn on scene 2. And this one, the resonance is going to sweep up and down at the same rate as the modulator levels from motion sequence 1, lane 1. So they sort of mod the pulse width and the resonance together. Scene 3. Scene 4. Scene 5. Scene 6. Now remember, this engages the non-harmonic components on the square wave modulation. Scene 7. And scene 8. So let's go in and look at the details of the shapes we've set up for our motion sequence lane 2. So for scene 1, we mentioned it's static, so our motion sequence has nothing going on at all. Our second sequence has our sweeping shape. Again, it's a 2-step shape, so it matches the 2 steps. I'm combining these 2 shapes together just to make it match the shape exactly, because resonance is sort of a logarithmic scale where our level is not. So I've got this little shark tooth thing. Now we've got a slightly different shape. This is our stepped values, so it actually rises and falls with the double pulse similar to our lane 1. So that's our lane 1, that's our lane 2. And our lane 5, again, is a simple rise and fall over 2 steps. And this is our double peak using the M shape. That's matching up with our lane 1, which is doing the 4 times pulse width mod. Finally, our sequence 7 uses a sinusoidal shape that's put together with 2 sigmoid sections. And then finally, we're back to the slow rise and fall that matches our Jacob's ladder type of triangle modulation that we have for our motion sequence lane 1. So as I mentioned before at the beginning of this video, we've got our real-time knobs assigned to a bunch of other parameters that we can twiddle in real time as we play, or you can turn on the arpeggiator and play over the top of the arpeggiator. So we're going to turn that guy on. We're on our motion sequence 2. I'm going to go ahead and make sure we're up where our resonance wave is doing its thing, so we hear both motion sequences. And so here's our arpeggiator. So hopefully you found that useful. As always, make sure you read the accompanying article at yamahasynth.com, part of the article series Manny's FM-Xplorations. Thanks again for watching, and we'll see you next time.